We're back at Honors Algebra 2 Pre-Calculus doing section 9.2 in the pre-calc book. So I'm on page 626 and we're going to talk about the nth term of an arithmetic sequence. We're going to do it the book's way, which is on page 626, but we're also going to talk about my way, which is logic. And I'm going to walk you through why I sometimes disagree with the way that something is presented in your book, not because the formula that they present for different circumstances are wrong, but because they require you to lean too heavily on memorization and not on logic, and I think that's a bad life choice. We have too many things to memorize in our lives already. We should be able to use existing knowledge and then apply logic to figure things out, and that's a better way to do most things. So let's first start with the logic, and then we're going to revisit the book and talk about the formula they give and why it's not wrong, it's just different. So let's think about an arithmetic sequence, right? So let's say I have some arithmetic sequence, a sub 1, a sub 2, a sub 3, dot, 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 all the way to a sub n, right, dot, dot, dot. Let's say I want a formula for the nth term, okay? Well, we can figure this out using a little bit of logic. So let's start by figuring out like how we'd find a formula for, let's say, the fifth term, okay? So that's not the number I meant. Okay, there's the fifth term, and we'll do the sixth term. Okay, so we're going to figure out a formula by a little bit of practice by finding some formulae for the earlier numbers, and then we'll figure out how we can take that formula that we've constructed and find a better way to write it for a sub n, right? Okay, so I have some a sub 1, right? And what I know is because this sequence is arithmetic, there's some common difference d, right? So to get from a sub 1 to a sub 2, I add d. And to get from a sub 2 to a sub 3, I add d. And to get to a sub 3 to a sub 4, I add d. And the same thing's going to go on forever, right? Add d, cool. Dot, 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 dot. Ad infinitum, which means till forever, right? To infinity. So that means that let's say I have some a sub 1, right? A sub 1 is given, it's just a number, right? Once I have that a sub 1 number, if I wanted to find a sub 2, I would do that by taking a sub 1 and adding to it one common difference, right? Well, that means that if I wanted to find a sub 3, I would take the thing I called a sub 2, which seems to be a sub 1 plus a common difference, right? And I'd add to it another common difference. So the point I want to make is that what that really looks like is that to get a sub 3, I'd have a sub 1, and I would add 2 of that common difference, right? And then to get a sub 4, right, I would take this term, which was a sub 1 plus 2d, right? And I would add another difference to it, right? So it seems to me that to get the fourth term, I would do a sub 4 plus 3d. Or, sorry, a sub 1. My bad, guys. Sorry, switching marker colors sometimes makes my brain overload. All right, plus 3d, right? Okay, so if we were to look at this pattern, right, I think what we can figure out is that if I want the nth term, right, if I want the nth term, so dot, 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 a sub n, it would be the first term, and then what I would add is I would add n minus 1 of the common difference. And this makes a ton of sense if you think about it, because you're already starting at a sub 1. So to get to 2, you only have to add a single d. But to get 3, you'd have to have 2d, right? So the reason that you have 1d fewer than what you're starting with, right, like than the number you want, is because you didn't have to add a d to get started at the beginning. You already started at a sub 1. So this is the formula that I use when I want to find the nth term of an arithmetic sequence, right? So this is what I use. And that's not wrong, and I think it's easier, and it makes total logical sense, and you can, if you don't have this memorized, you can intuit it by some basic inspection of looking at a pattern, right? Now, what the textbook does, and again, it's not wrong, it's just different, is the textbook gives you this formula. They give you the formula. So in the book, on page 626, they give you that a sub n equals dn plus c. Now, you might be like, but Hogan, what is this c? Come on. And that's a good point, and that's why I disagree with the book here. They then say where c is a1 minus the common difference, right? And so here's the reason I find that annoying. Like, I now have to memorize that stupid thing for c. There are lots of c's in math. There are c's in science, as in the speed of light, right? There are c in math where it's the constant of integration when you're in calculus. There are too many darn c's for me to memorize that this one particular arbitrary c is a sub 1 minus d. Now, if you were to take my formula and their formula and compare them, what you'll find is that they are the same formula. Theirs just requires that you memorize this stupid arbitrary c. Because if I take their formula, I get dn plus a sub 1 minus d, right? If I put all the d's together, right? So if I put a sub 1 at the front, and then I have dn minus d, I can factor a d out, and I get that a sub n is a sub 1 plus if I factor a d out, I get a d times the quantity n minus 1, which is the same answer I had, just because multiplication is commutative, it's in the opposite order. So what I want to point out is, like, the book formula is fine and it's great, but sometimes some of these textbook formulae sort of take away your ability to logic through a problem, and I think that that's a fundamental mistake when we're dealing with mathematics, right? Sometimes people think math is a lot harder than it is because when we give obscure formulae and we randomly assign letters to things, we make it more difficult instead of just realizing that most of the math we're doing is fundamentally pretty logical. So I'm going to use this formula from here on out. If you want to use the book's formula, this one right here with this C, there's nothing wrong with that. I'm just not going to do it. Again, I don't care what you use as long as you're able to do the problems correctly without looking off someone else's paper. But I find personally that I would rather lean on logic than lean on excessive memorization. So, moving on. Just a reminder also that there are kind of two types of things that we do in school, right? We talk about knowledge and cleverness. Knowledge is the stuff that you can memorize, right? And cleverness is your ability to apply that stuff under pressure or in unconventional ways. And so we definitely have to have knowledge. We have to have some stuff memorized. We have to know what it means to be arithmetic. We have to know how to do addition, subtraction. We have to know our unit circle. There's lots of stuff we have to know. But most of what matters is if you can take that knowledge and apply it in a situation. Because especially now, in a very digital age, you can often look up a lot of the memorization stuff on the internet in the middle of working on a collaborative project or whatever. But it's how you apply that knowledge that you might not be able to look up, and you have to find that cleverness. All right, so let's do an example now. So we're going to go ahead and find the nth term of a geometric, or of an arithmetic sequence, right? Sorry. Geometric is the next section. All right, so we're going to find the explicit formula. Remember, explicit means that that it's in terms of n, right? So we're going to find the explicit formula for the nth term. All right, and this is going to be an arithmetic sequence, and we're going to find the explicit formula for the nth term. So let's go ahead and do one that we've already seen before, right? 1, 3, 5, 7, 9, right? We saw that in E1. All right, so again, what we're going to do here is we need to know what the first term is, right? So in this case, my first term is a sub 1 is a 1, right? And then I need to figure out what the common difference is. Well, it seems that by visual inspection, I can see my common difference is a 2, right? So the difference is a 2, right? So my nth term then, based on what we just discussed, should mean that I take the nth term is a sub 1 plus n minus 1 times the common difference. So my nth term should be the term I start with, which is a 1, plus an n minus 1 times a 2. Now, that's a great formula, and if you want to do that, that's fine. If you're somebody who wants to clean this up and distribute the 2, that's also fine. If you clean this up, right, you're going to get this a 1 plus a 2n minus 2. So the other way you might see this formula is as a 2n minus 1, and that's also great, right? Either of those would be fine, right? Sometimes after you find the formula for the nth term, right, so let's just go ahead and cheat and call that part A. Sometimes after you find the formula for the nth term, they might ask you to use it to find a sub 100. Now, if I were just listing the first 100 terms here, that would take forever. But since I know the formula for a sub n, and I'm going to use this one because in reality I probably would have been too lazy to rewrite it this way. It's up to you, but in reality, I probably would have just kept it like this, so I'm going to do it that way. Either one would be fine. So I'm going to find a sub 100. Well, using my formula, that's going to be a 1 plus a 99 times 2, right? So that's going to be a 1 plus a 198, right? Because it's 2 shy of 100, so I'm going to get a 199. Now, if you'd done it using this formula instead, you would get the same thing, right? You would have had a 200 minus a 1, which again gives you the 199. So again, sometimes you're going to be asked to write an explicit formula, and then you're going to be asked to use it. That's the only rational way to get to term a sub 100. Like, you don't want to get to the 100th term just by working your way up. That's a terrible life choice.